In this video, I want to discuss how to tighten your belts and calibrate your tool head on a K1C, K1, and K1 Max. So the best thing to do first is to get M3 12mm screws, insert them on both of these sides, right here, where you can tighten it, the belts. And you want to screw them in all the way so that both belts are as loose as possible. Then I unscrewed the left motor and the left belt. This is the top belt. I unscrewed it about halfway as a baseline, and actually that's probably the easiest way to do it, to have a baseline while you're working on the other side. So yeah, I put this around about the midway point. You can actually tell right there. But now the task is to tighten that, or tighten the bottom belt, which is loosening this screw slowly, until it matches the same tension as the top belt, which is our baseline right here. Okay. The way you do that is you go to fluid or whatever you're using, maybe the standard Creality interface, and make sure X is at 110. That makes the tool head directly in the center. Okay, and you need that because you could test the tension by simply plucking this belt, the top belt on this side. So the top belt on this side is the same length as the bottom belt on this side. So they, when they're equally tensioned, they should sound exactly the same. They should have the same exact tone and frequency, right? The top belt on this side corresponds to that motor. Bottom belt on this side corresponds to that motor, right? So once you have it dead centered, remember 110, you can start plucking it, right? Right, this one sounds roughly like this. Okay, you're gonna do the same thing for the bottom. The reason you do the bottom is because it's the same length as the top one here, and conversely, the bottom one here is a bit longer, and the top one here is a bit longer, right? This corresponds to that belt, and this corresponds to that belt. So you could use whichever belt you want, but I prefer using this one and then this one. Okay, so yeah, if this one is a lower pitch than this one, you have to loosen that screw to tighten the bottom belt. Okay, keep tightening the bottom belt until this sounds exactly like this. Conversely, it will work with the other belts too. So see? Okay, now this one again. Sorry. Yeah, so you notice that these two were different frequencies. Let me point that out again. That's because the bottom one is shorter than the top one here. Obviously, they will have two different frequencies with the same tension. And the bottom one here is, sorry guys, top one here is shorter than the bottom one. And here, bottom one is shorter than the top one. The shorter one will have the higher pitch. The longer one with the same tension will have a lower pitch. See, that's why. Anyways, now that you know all that sciencey stuff, you could actually do the, there's a standard 150, what is it? The 150 millimeter, 110 Hertz test. So easy way to do that is you go to your interface, type in 150 for Y. Okay. Once you tap 150 for Y, or actually no, it's 140. I'll just type in 140 for Y. It'll be exactly at 100 and, yeah, it'll be exactly at 150 millimeters. Right. See? Yep, exactly at 150 millimeters. Okay. And so you could do the pluck test here. You'll notice mine isn't 110 hertz, but you could further tighten it, re-baseline it to be tighter on this side, and then you're going to have to tighten this side even more. The belts, that is. That means unscrew the screws. Eventually you'll get to 110. But right now, as it is, everything is completely equally tensioned. And the last way you could actually test that is when you go through the input shaping software, which is right here. Okay, Fluid has belt shaper calibration that you could run and test resonance graphs, which calibrates or gives you the resonance of the X and Y axis. Okay. When you do that, as you are doing that, you'll notice both of these that are the same frequency will resonate at the exact same time. One, obviously, so it starts with the left side, A, motor A. This will resonate really hard because motor A is the top belt. This will resonate at the same time, but less so, okay? Conversely, you'll see the same thing. This will resonate at the top, but this will resonate less so at the same time. Then when it gets to belt B, you'll notice that it's going to resonate here, or sorry, the bottom one and the top one. So the bottom one is going to be, you'll see it wobbling at its resonant frequency really hard, and the top one will resonate at that same frequency lightly. And then you'll see it here too. The bottom will resonate really hard. The top will resonate a little bit because it's not the one under load right now, but it is partially affected because of the, it's all connected by the tool head. So once you verify that as input shaping is happening, that these resonate at the same time, these resonate at the same time, you're good to go. Now if you want to tighten your 150 millimeter 110 hertz, if you want to do that, you could do that. I'm choosing not to do that because it actually doesn't make that much of a difference. Although the most important thing is that all your belts are tightened, all the same with respect to one another. So let me show you some graphs that I generated. So I ran the belt shaper calibration, the test resonance graphs, and belt shaper, these two graphs is what it looked like. The important thing you want to see is that the walls of the power spectral density as it goes up, that they hug each other for both belts, both belt A and both belt B. That is the most important thing. Same thing here. They hug. That means they're increasing with power, resonance power, and decreasing with resonance power, roughly around the same frequencies. That's what it means. There is obviously going to be deviation from run to run at the highest peaks and in between that, which is what you see here and here. The deviation is simply because it's a lot of energy going through. The sensors aren't actually granular enough to detect everything that's going on perfectly. You can run in 0.5 hertz steps and 0.25 hertz steps, which I've done. Let me show you what that looks like. So you can, whoops, don't know where that is. Anyways, so the important thing is, like I said, if you run more granularly, these graphs will look almost identical. If you run in 1 hertz steps, they can vary in between here, okay? Just something to point out for you. What's important is, again, the walls hugging, the walls of this peak hugging each other, okay? And so the secondary thing that's important is the similarity in the peak. So it should be right around 95 or higher. I got 94 on this one, 95.8 on this one. And then you could do your input shaping on the tool head, X and Y. This is what my X looks like right here. This is after I've actually taken out, I did the spring mod on the tool head. I took out the springs, replaced it with pen springs. Highly recommend, otherwise you'll get an extremely ugly graph here. So now I got this for X and this for Y. Usually I get higher, I get like over 8 here, e to the 5, but that's what this turned out to be. But if you are getting really messy X values even after doing the spring mod, what you need to do is you need to clean your rods completely with isopropyl alcohol, because the X rods don't even need to be lubricated. If you lubricate them, it'll add noise. It'll bind it up every once in a while, and it's not good. So just clean it with isopropyl alcohol. Don't even lube it. It's a self-lubricating graphite bearing in there, and that's all you need to know. As for the Ys, you need to lubricate those once in a while, have maintenance on that. So make sure you do that. If this graph, if the Y graph here is getting a bit low, you know, drop it down to 6, looking a bit messier, you should lubricate this with some thin oil. And yeah, that's all I have for you. That's what it looks like. And everything's tensioned exactly as I want it. Hope you learned something today. Please give me a like and a comment. If you have any questions, let me know. Thank you very much.